Hello again, AP statisticians, back with the first lesson of the second unit. So the first unit is all about the data collection or setting up experiments, and the second unit is about the kind of the first wave of data analysis, which would be the means, medians, modes, range, IQR, standard deviation, and the like, along with the data visualization piece, which would be mainly box plots, stem plots, bar charts, histograms, dot plots for our work here. And we're going to start with the 5-number summary and box plots. So this is kind of the first data organization piece that we have. The 5-number summary is these 5 values here. And when you get a set of data, probably the easiest way to get these values is you can put them into your calculator using stat edit. And it will bring up your lists. If you put them into stat edit, you can, if you have something in your lists, you can highlight the name of the list and hit clear and hit the down arrow. And you put the values into your list. And once you've put all the values into your list, you exit out of your list by a second quit or something like that. And then you go back into stat calc one variable stats, which is the first one under stat calc. And when you do that, it'll ask which list it is, and the default is list 1, and that's most often the one you're going to use. If you have a newer operating system, it'll ask you frequency list. Don't need to worry about that right now, and you just calculate, and it will give you a lot of values. But if you scroll down, it has the 5-number summary. This is listed as min X and Q1 and median and Q3 and max X. And that is your 5-number summary. Now, to get a 5-number summary from an actual list of values, if you're looking at them, sorry, I don't know why some of these show up as being hyperlinked, but probably the easiest scenario is if you have an odd number of values and they're all unique. Okay, so to get to the median, what we would do is the typical kind of cross off, one from the bottom, one from the top. Again, notice that these are in numerical order, so we can do it this way. If they aren't in numerical order, it's a lot more work. But what happens is we end up with 34 being in the middle. So that's our median. And of course, we have the minimum here and the maximum here. Now, to get the quartiles, to just understand where the quartiles come from, the quartiles are the 25th and 75th percentiles. And what you would do is if the median is an actual value, like it is here, then we basically cross that out and just find the middle of what's left. So in this case, it would be the middle of these values right here is Q1. So as you can see that we've got 7 values. So right here, that's Q1. And then similarly, it'd be the middle of these values up here, and that's Q3. Now again, the calculator will do this for you quickly, but there are some times where they'll leave out some values to make it tough to do on a calculator, and you'll have to still have an understanding of how to calculate those. The girl values here, now there are 10 of them. Clearly we have the min and the max again, and they're all in numerical order, which makes it a little easier. Now in this case, when we start to get to the median here, what happens is when it's an even number of values, we crossed out the 38 and 39 together. So the median is actually 38.5 here, which is the average of the middle values. And that's how you find the median if there's an even number of values. So the general rule is number of values plus 1 divided by 2 will tell you where in the set the median is. So for instance, in the first one, 15 plus 1 over 2 is 16 over 2. So that means the 8th value is the median. And you can look at 1, 2, 3, 4, 5, 6, 7, 8. Okay, now in the next one, there were 10 values. So it's 10 plus 1 over 2, which is 11 over 2 or 5.5. So that means it's between the 5th and the 6th values, which as you can see here, 1, 2, 3, 4, and then 5 and 6. So between those two values is the median. So that's a quick way to figure out where in a set a median is. So you don't have to do the whole crossing off the top and the bottom and so forth. Again, that's not, just to be abundantly clear here, that doesn't mean that 8 and 5.5 are the medians. It's just which value in the ordered data set, counting from the bottom or from the top, is the median value. So now in this girl's example, where 38.5 is the median, because the median isn't a set value, we don't actually cross out either value there to find the quartiles. So what we do here is we circle the whole bottom half and we circle the whole top half and find the middle of each one, and the middle of each one is the median. So the middle of the bottom half here would be of the bottom 5 values, the middle is 30, so that's Q1. Of the top 5 values, the middle is 49, so that's Q3. So our 5-number summary there would be 25, 30, 38.5, 49, and 53. Now in this special case at the bottom, we've got an odd number of values, so we know the median will be in the middle, and it will be a value, which is the 7 there. Okay. We have 3 below and 3 above. So again, it's an odd number. So the Q1 and Q3 will be an actual value rather than the average of 2 values. And in this case, it's just we got 7 again. So Q1 is actually also 7. So we've got a minimum of 4, a Q1 of 7, a median of 7, a Q3 of 9, and a max of 9. So as you can see here, the 5-number summary doesn't necessarily have to be 5 unique numbers if the numbers are all bunched together like this. Now, we do need to be able to calculate outliers as well. So outliers are values that have a statistical meaning in terms of how far they are from the center part of the data, not just the median, but how far are they from the kind of middle 50% of the data. So when we look at this, first thing we need to know about outliers is we need to know how to find the interquartile range. So for instance, if we have the values 1, 2, 3, 4, 5, 6, and 17. In this particular example, there's 7 values. Okay, so the median here would be 4. Okay, so that's the median. Q1 again would then be the middle of the bottom half here, and since we can cross out the median, so Q1 is the 2 there, and Q3 would be the 6. So our IQR in this case is 6 minus 2 or 4. Okay. Now to find if we have outliers, and clearly I kind of set up this example to have an outlier, but there's 2 different potential outlier types. There's a low-end outlier or there's a high-end outlier. And notice this is less than and more than, not less than or equal to and more than or equal to. So on the low end, we'd take Q1, which was 2, minus 1.5 times the IQR, which was 4. Okay, here's the IQR. And so that ends up being 2 minus 6, or negative 4. So any value less than negative 4 would be an outlier in this example. Obviously, we did not have any values less than negative 4, so there are no low-end outliers. Now, in the high end here, Q3 again is 6, so that would be 6 plus 1.5 times 4. Okay, IQR is still 4. So this ends up being 6 plus 6, or 12. Which means any value bigger than 12 is an outlier. And as you probably would have guessed from the very beginning in this example, 17 then is an outlier. Now, we can't just say 17 is an outlier by looking at it. We have to actually calculate to make sure that it is. Now, keep in mind, if we would have had a negative 4 or 12, those would not have been outliers, but anything less than negative 4 would have been an outlier. Anything more than 12 would have been an outlier. So if we would have had another value in there that was 13 but everything else stood the same, that would have been an outlier. Now the way this shows on a box plot, just to give a little example here, is here's a couple different types of box plots. This is what's called a modified box plot, and this is what we will use consistently this year. And a modified box plot just separates out the outliers, okay? So the outliers get their own X or their own asterisk or their own dot or whatever it may be, but those are outliers. In this case, there were 3 outliers on the low end in this data set. Now, a couple things. First of all, that means there's 3 individual values down there. But this low whisker here, okay, this lower whisker, this does not go to the result of the outlier formula. That goes to the smallest value that is not an outlier. So that is a value in our data set. So it could have just been some value that was just below the lower quartile. In this case, it was very close to the outliers, but it was not an outlier, as you can see by just the difference in those values there. Otherwise, the Q1 and the median and the Q3, in this case, the max, those are all just standard. Those don't change because of outliers. Outliers are still part of the data set. So they were included when we were finding median. They're included when we were finding quartiles. They just get a separation in the graph here, or in that calculation, because they are distinctive values that are further than 1.5 of these. So again, this is the IQR right here. Okay, from here to here is the IQR. So anything that's more than 1.5 of that length is an outlier. Sorry, anything that much less than Q1, 1.5 of that length less than Q1 is an outlier, which were those 3 points on the end. And as you can see, 1.5 that length going up, there was not any outliers there. This over here is what's called a parallel modified box plot. Again, the modified just means that we have the outliers, but parallel means there's more than one. And you can see we label them A and B. You do always have to label your box plots. It tends to be males and females, or seniors and juniors, or whatever it may be. And you can see in this case, there were also a couple of outliers. One outlier in the B group, which was the male actors in this situation, and 3 outliers in the female actors based on the labels down here. Notice in this box plot, they use the exact same scale. They're on the same scale, and they just kind of both float in space, one on top of the other, above that scale. The scale always is standard at the bottom. You will never label the actual quartiles and things on the box plot. If you get in that habit, it can cause you to distort your box plot, and a space of 3 looks the same as a space of 23, because you just draw the box plot kind of perfect and then try and put numbers around it. So in the end, each value in the 5-number summary gets its own vertical line. The box connects the middle 50%, so the box connects the Q1 to the Q3. The whiskers go out to the lowest non-outlier and highest non-outlier values, like we saw right here. And then the outliers get their own dots. Now keep in mind, a lot of data sets don't have outliers, but a fair number do as well. So you can see the exception listed here is the smallest or biggest non-outlier value gets a line if there are outliers. So that's the creation of a box plot. What we'll get into a lot more is that you have to be able to describe box plots and how they compare to one another, more so than creating them. Your calculator can create them. And this is the last thing I'll mention here, is if you have done the stat edit, and so you have values in a list, and you put the values into a list, okay, then you can quit out of there and go second y equals up in the top left on your calculator, which is actually stat plot. And when you go to stat plot, you can go into your first plot, make sure it's turned on, and for type, you'll hit the over until you get to the box plot that looks like this, that actually has the outliers. Okay, that's a key piece. There's 2 types of box plots there, one that doesn't show the outliers and one that does. You want the one that does. Make sure your list is correct. Frequency can always stay 1. The mark doesn't matter. And then you go to graph. Okay, and when you graph, it might not show you a centered picture. So the last thing you would do is hit zoom, which is up on that top row of gray buttons. I guess it's gray on mine, maybe not on yours, but zoom 9, which is zoom stat, and then it will show you your box plot. So that there is the process for actually creating a box plot on your calculator. If you want parallel box plots, then you just have to do plots 1 and 2 and turn them both on. And you probably want to make sure you don't have anything in your y equals for this, because that can create a different line or graph that interrupts with your box plots. But so that is the 5-number summary and box plots. Thank you for listening. As always, please let me know if you have any questions.